Hello everyone. So in today's video, we'll be looking at the attention mechanism. We'll be going through in depth and we will use visualization in order to understand this important concept. So in the attention mechanism, the most important, we'll be doing the self-attention mechanism. So let's get started. So now we already know that any word in attention obviously is defined by three vectors. What are those three vectors? It's called the query vector, the key vector, and the value vector. And what I have also mentioned previously is that both of them have to be, the key and the query have to be of the same dimension. Okay, so this is, even if you haven't seen the previous videos, don't worry, but this is something that you need to know. Okay, that you see there are five values over here. Here also you have five values, and here it can be any number of values. Right now we are taking 6. Okay, now the question is, let's say you have a sentence. Okay, and the sentence is Sunday is a dash. Now obviously when you are going to have an let's say a dash, you're going to fill that dash with a word. So what is the correct word? Is a car, is a holiday, or is a city? Obviously the answer is a holiday, right? Sunday is a holiday. It's not a city, it's not a car. Now the problem is computer doesn't understand this, right? Because this is a human language. This is English. It cannot understand English language. It only understands zeros and ones, right? So what we do something as embedding, right? So Sunday is converted into this embedding. Okay, this is nothing but a series of number. Okay, see, this is called word embedding for Sunday. Similarly, this is the word embedding for is. The word is, this is the word embedding for the word and this is the, let's say, the word embedding for this dash. Okay, this is the word embedding for dash, and this is the dash that we need to predict, right? So how this will happen? So obviously we have seen, so there are three vectors, but instead of a word, what you do, you give a word embedding. Why? Because a word is not understood by a computer. Only the embeddings are understood. So let's try to understand in detail, and let's try to visualize this. So how are you going to get the query vector, right? We have seen over here, right? We need the query vector. So we have used the embedding. How we are going to do? We will say our query vector is nothing but a query matrix. So this is an randomly initialized matrix, generally which are having parameters that will be learnt. Okay. So this is a matrix that is random in nature in the start. Okay, this is what has to be learnt, and the word embedding that we are going to have, that we are already having over here, right? So these were our word embeddings, as we have already seen. So we'll take these and then we'll multiply it with a matrix. So let's take the word Sunday and we are going to find the query vector for this. So how you're going to do? We'll use the same formula, query matrix into word embedding. So our query matrix is over here. As you can see, this is our query matrix, and we are going to multiply it with this particular embedding, which is the Sunday embedding. If you remember from over here, 0.33 minus 0.78 and 1.77. If you remember, this is the same thing. Okay, 0.33 minus 0.78 and 1.77. But there is a problem. This is 5 cross 3 and this is 1 cross 3. They cannot be multiplied. So what you will do? Obviously you will take a transpose of this. You will take a transpose. So what you do, you keep the query matrix as it is, and then you take the transpose of the word embedding. So now it's 5 cross 3 into 3 cross 1. Obviously when you multiply them, what you'll get? You'll get 5 cross 1. So once you multiply this matrix with this vector, you get this particular vector. Okay, now this is the query vector. What is this? This is the query vector for the word Sunday. So can't we do the same thing for other words? Yes, we can do that. So we'll take the word is, and the thing is that we are going to use the query matrix which we have already used in this, the same query matrix. The query matrix does not change in one particular iteration. Okay, in one particular epoch it does not change. Only when you do backpropagation it changes, but now not now. So we'll take the same query matrix which was there, we take the same query matrix over here, but now we change the word embedding. Now you're going to use the word embedding of the word is. When you do the multiplication, you finally get another vector. This is 5 cross 1. Okay, having understood this, can't we just write it in, like, let's try to look at it. Okay, so what we did in the Sunday part, we took the query matrix, we multiplied with the word embedding of Sunday, which was 0.33 minus 0.78 and 1.77. So we got this particular vector for our, so this is the query vector of Sunday. Same thing, we took the same query matrix over here. This is the same query matrix. However, we took the word embedding of the word is, right? Word embedding is different over here because the word is different, and so we got a completely different vector. Now why don't we, instead of doing these multiplications in two different steps, why can't we just club them, right? We'll keep the query matrix because it is the same, so that is there. And what do we do now? We make it into a smaller matrix, right? Those embeddings which were vectors have been clubbed into a matrix, and you see the answer is the same. Again, the answer is the same. You see over here, this was the query matrix, this was the embedding of Sunday, and this was the embedding of is, but now it has been converted into one step matrix multiplication. And what you have got? You have got the query vector of Sunday, and here you have got the query vector of the word is. Okay, having understood that, why can't we just do something like this? Okay, so these are the two words that we have already gotten, right? These are the for these two words we have already gotten the query vectors, so why can't we do the same thing? Well, for these words as well. So you take the word okay, so this is the word, this is the embedding. What you do, you transpose it. Same thing for this dash, you take the embedding, you transpose it, and then you stack them together. So this was the, over here, this is the embedding of the word and this is the embedding of the dash. Okay, and you keep it over here only, you keep this over here, and then what you do, you come over here and you attach it over here just as a matrix. So you can see over here this entire thing gets attached. So now can we say this same query matrix, it remains forever over here, and now this is the entire embedding for all the words in just one matrix. This is for Sunday, this is for is, this is for the word and this is for the word dash, or it's not a word, I mean it's for dash. Okay, what you will do, you are having a multiplication, right? So what you get, another matrix. So this is proper matrix multiplication. So this was a 5 cross 3 matrix, which was the query matrix. You have the entire embedding at once, which is 3 cross 4 now. So once you multiply 5 cross 3 into 3 cross 4, you get 5 cross 4. And what you call this? This is the query matrix, queries matrix. These are not, sorry, not query matrix, these are queries, right? Remember, each word has, the word has, a word embedding has three things. Basically, you just take a word, it has a query, it has a key, and it has a value, right? So now we have got all the queries in one particular to say operation, which is just matrix multiplication. How simple that is. Now the question is, okay, fine, can we do the same trick for the keys? Why not? What you do, okay, now you have sent query is done. Now we will try for the key. So this is what we have till now. Let me just remove the query matrix and let me remove the answer. Okay, we have removed them. Now what you do, instead you keep the embeddings the same. Now you use the key matrix instead of the query matrix. So what you will get when you do this multiplication, you will get the keys matrix, or rather, let's say this is not a this will be the keys. So you have already gotten the queries, now you have gotten the keys. Now anything that you want more, obviously you're done with the keys, now you want the values, right? Now what is the answer for this? Very simple, we have already seen. So what do, you remove this, right? You remove this and then you bring on the value matrix. Now here value was 6 cross 3. Why? Because we have taken, these are what to say, or 6 cross what to say, I think this will be 4. Okay, I think this will be 4. Let me just check one more time. No, it will not be 4, it will be 3 only. Okay, so 6, right? We are going to have 6 over here and then cross 3. So what you do, you multiply it with 3 cross 4. So 4, why? 4 words were there, and our matrix was 6 cross 3, if you remember correctly. Why? Because 6 we had taken for our to say your values. Okay, so when you multiply 6 cross 3, what you get? 6 cross 4, right? So this is what our values are. Same steps, you just keep the embeddings as same, and the value matrix is obviously the difference here. In the queries you had the query matrix, in the keys you had the key matrix, and now in the values you have the value matrix. Okay, 6 is something that we had defined for ourselves because key were, so queries and keys were 5-dimensional, right? And your values was 6-dimensional, if you remember correctly. Okay, so having said that, let's go further. So now we have also sorted out our values. Now what we can do, so we'll keep just all the things in our same place. So now we have gotten our queries, we have gotten our keys, and we have gotten our values. Now for the further steps, you don't actually need the values right now. So what you're going to do, you're going to remove, and I'm going to make some space. Okay, you only need the queries and the keys. Why? I'll show you. Because we need to apply this formula. Okay, so once this formula, how we are going to apply this formula, you can already see there is q and there is k transpose. This is the transpose. Okay, So this is the query, but what we need to do, we need to first transpose it beforehand. And this is something that is different. There's some places they won't transpose, there are some places that they will transpose, and the reason for that is it depends. Okay, whatever you have gotten, both are correct. So what you do a transpose. So 5 cross 4 will become 4 cross 5, and same thing for keys also. So both are now transposed, right? So both are transposed right now. So now this is, you can see, since these are the four words, you can see Sunday is a dash. That's not a word, but you get the point, right? And these are the query vectors. So this is the query vector, this is the query vector for Sunday, and this is the corresponding key vector for Sunday. Okay, and the same thing goes for all the other words. Now what you do, you apply this formula as we have already talked about. So we'll take the 4 cross 5 of queries as it is, and we are going to do a transpose of the keys. Okay, so what happens, this is 4 cross 5 and this is queries, right? This is queries. Now this is keys, but you are taking the transpose of that, because in the formula you have to take transpose of keys. So this will remain 4 cross 5, and this will become 5 cross 4. Why? Because we are doing a transpose. So you can see this is already become 5 cross 4, and this was 4 cross 5 from before only. We can do a simple matrix multiplication. Yes, we can, and we'll get an answer of 4 cross 4, right? When you do a 4 into 5 and then you multiply with a 5 cross 4, these two remain, these two have to be same, and then whatever will be the final will be these to say extreme values, right, which is 4 cross 4, right? So we have gotten our answer 4 cross 4. Now there is one more thing that we are able to see in this formula, which is divide by the root of k dimension. What is k dimension? K dimension is basically your dimension of keys. What was the dimension of keys? It was 5, right? Let's go back and see one more time. Come on. So we can go back over here. Okay, let me go instead of here, instead of value, we are going to go for keys, right? So this was the key matrix, right? This was 5 cross 3. What was the dimension? 5. So let's quickly go forward. Okay, let's go forward over here, and we were over here, right? We were over here in the list, this one. Yeah, so what we are having, we're having the dimension of 5, right? What you take, you do a square root of 5, you'll get 2.236. So you take this matrix, whatever you had got, divide the whole matrix by 2.236. Once you do that, you get this particular answer. Nothing fancy. Okay, so what you do, the last step was applying. You can see over here, last step here, where is the cursor? Here. You can see the last is softmax. So what you do, you apply the softmax to whatever we have gotten up till here. Correct? So what you do, let's try to, so this was the answer. So this was the answer, right? When you do a softmax, you use this dimension. You're going to use softmax along the last dimension, as they say. Okay, dimension equal to -1. Basically, they are going to do it row wise. Okay. So you already know what softmax is. I'm not going to explain this particular video. There's already a video on this channel explaining what softmax is with the formula and clear intuition and understanding. So what you do, you apply it on this dimension, the row. Okay, so when you do that, you get particular values. And what is the good thing about this is, if you sum all along the rows, you will get the answer as 1. Okay, so if you add 0.64 plus 0.03 plus 0.23 plus 0.01, you'll get 1. Now this is one thing that I want to clear. Since I had taken random values myself, if you do a softmax of all this, you won't actually get these numbers, but very close to these numbers. Okay, in fact, not even, let's say something like these numbers. Okay, because you see minus 12.88 is the smallest, and you can see over minus 15.919 is the smallest among all the four. You can see 0.03 is smallest among all the four. Second, this is the second smallest. You can see this is the second smallest, and the largest value is 1.12. You can see the largest value is 0.64. So this is how it has been arranged. Obviously, this is not a direct exchange, because if you do a softmax of all these four, probably you'll not get these values, because I wanted to make it to show it to you in such a way that you will be able to understand. Okay. Same thing for the second row as well. You take this particular row, you do a softmax, you'll get this. Again, sum all of it, you'll get 1. Okay. Same thing for the third row and same thing for the fourth row. So what we have got, so once that is done, we have got the full final answer to whatever the formula was. The formula was softmax of query into key transpose divided by square root of k underscore dim. This was the formula. We have finally gotten this entire thing is this. Now, what is the last step? The last step, in order to get the final values, it is value matrix, which we had already found earlier, into the softmax output. Now you see this was 6 cross 4, right? Now this is 4 cross 4. So obviously if this 4 and this 4 will match, this 4 and this 4 will match. So the answer will be 6 cross 4. And you can see over here the answer is actually 6 cross 4. Okay. Once that is done, what you are going to do, you're going to take a transpose of it. So once you got this, you got the transpose of it. So now it's again these 4 words over here, you have gotten the final values. Okay, so I hope this is that. Yeah, so I hope you like the video. If you like the video, please like and subscribe. Thank you very much and bye.